Example 11 has another piecewise defined function, so it's again asking for the continuity at x equal to 3. So we're going to do the same standard procedure and check step number 1, how much is h of 3, because 3 is the border point in this particular problem. That's what they're asking about. So keep in mind that when you write h of 3, that literally means we're allowing x to be exactly equal to 3. So think about which equation allows x to be exactly equal to 3. It doesn't take a whole lot to notice that the second line says x equal to 3. So when x is equal to 3, that uses the equation 7. And in this case, I am supposed to replace all the x's with the number 3, but there are no x's to plug in. So that's it. We're done with step number 1. It's just 7 at the end. So now step number 2. And in step number 2, we're looking for the limit as x approaches the border 3 on this function h of x. So again, keep in mind that when we say x approaches 3, we're saying x is going to get closer and closer and closer to 3, but without ever touching 3 itself. So which one of the conditions allows us to do that, to get closer to 3 but not touch 3? Well, turns out that it's the first condition. That's the condition that allows x to be not 3. So we're supposed to use the equation that's written right there, or the expression rather. In this case, the limit as x approaches 3, and we're going to write down x squared minus 9 divided by x minus 3. And again, we are approaching the 3, so let's plug it in. So we get 3 squared minus 9, all divided by 3 minus 3. And unfortunately, this is an indeterminate form, 0 over 0. So that means we cannot pause right there. We cannot stop right there. We have to fix this. So how do we fix it? We start over with the limit as x approaches 3 on h of x. And we say that this is the limit as x approaches 3 and x squared minus 9 divided by x minus 3. But then we try to factor everything. Turns out that for this problem, we can factor the numerator again as usual. So the x squared minus 9 can be turned into x minus 3 times x plus 3 because it's technically a difference of squares. So we're going to do that on the numerator and leave the x minus 3 on the denominator. So now we cancel these x minus 3's and we get the limit of x approaching to 3 of x plus 3. And 3 plus 3 will be 6 eventually. So on one hand, the first limit turned out to be a 7. On the other hand, the second limit turned out to be a 6. So what do we say now? Step number 3. The first answer is h of 3, which is 7. That's not a limit, by the way. I'm sorry if I said limit. That's a mistake. It's just the 3 plugged into the h. The second one is the limit as x approaches 3 on the function h of x, and that turned out to be a 6. So now the 7 and the 6 are not equal again, which is bad for this problem because that means that the function h of x is not continuous at the point again, x equal to 3. So unfortunately, the function is not continuous. Now let me ask you this in preparation for the next example. Is there a minor change that we can make in this problem so that the function becomes continuous? So if I give you an eraser and a pencil and I allow you to erase one little thing on the paper and replace it with a different number, can you make the function continuous? You may be wondering about this guy right here. If I erase it and put the number 6, for example, then I'll end up with a 6 right here, and all of a sudden everything becomes continuous. So unfortunately for this example, we cannot do that. We cannot just erase the 7 and put a 6 there. But in the next problem, we are going to be allowed to pick the number that makes this function continuous. So we'll take a look at that next. So that's what's going on in example number 12. The function is called p of x, and it has x squared minus 25 divided by x minus 5, and the second line has a c. And the question is, what should c be so that the function is now continuous at the border 5? So we're going to do, again, step number 1, step number 2, like we did in the last problem. Step number 1 says plug in the 5 into the function in this case it's called p of x. So we're going to plug in 5 because 5 is the border. And notice that when x is equal to 5, your answer is supposed to be C. And remember, C is just a random number that you have to choose eventually yourself. Step number 2 is to look for the limit as x approaches the border 5 on this problem p of x. So in other terms, we're looking for the limit as x approaches 5, and the equation is x squared minus 25 divided by x minus 5. Why did I use this equation? I use this equation because x is approaching 5, which means it's not equal to 5. And when x is not equal to 5, we are expected to use the first equation. By the way, if I plug in the 5 right now, I get 5 squared minus 25 divided by 5 minus 5, which is 0 over 0, and this is kind of bad. It's an indeterminate form. So because it's an indeterminate form, I have to restart and look for the limit as x approaches 5 and do some factoring. And again, I notice that the numerator is a difference of squares, so I can write x minus 5 and x plus 5 instead of the old numerator, divided all by the x minus 5 that was on the bottom. So basically, I just changed the x squared minus 25 into x plus 5, x minus 5. Once I do that, I'm able to cancel some things out. And I'm left with x plus 5. So this is the limit as x approaches 5 of x plus 5. So keep in mind, x is approaching 5, plug in the 5 right there, and you get 5 plus 5, which is now 10. Okay, step number 3 is where we decide what should C be so that the problem becomes continuous. So on one hand, we want a C as a solution. On the other hand, we discovered that the limit was equal to 10 on this problem p of x. Okay, so I want the first box and the second box to match, to be identical. So what should I make the C in this case then? If I want the boxes to match, then I should make C be equal to 10. If I make C equal to 10, then the function p of x will become continuous at the point that we care about. Will become continuous at the point x equal to 5. So that's basically what I was talking about in the last example. So sometimes we have a power to change the number in the problem to make some function continuous. In this case, the power allows us to change C to be the number 10. And once you make C equal to 10, then the first box, the second box will basically match up and everything becomes equal. And that means the function becomes continuous. So that's great. And that's everything here.